In my last video, I showed you how I built the game Minesweeper from scratch using JavaScript. What I didn't tell you was that took me about 3 hours of coding to get it done. So I was curious, how long would it take AI to write the same thing? So I fired up Claude Code and gave it some prompts, and over the course of a few prompts, I got a similar working version of Minesweeper that took me a little over an hour to do in Claude Code. Then I thought, well, how does the code itself compare to what I wrote? So let me step you through the code that it wrote and compare it to what I showed you in my code from the last video. Now, I haven't taken too close of a look at this yet, so we're going through this kind of live. So first, let's look at the actual game. So this is the version that AI wrote, which I have to admit looks nicer than mine. It does have nice color coding that I did not add into mine yet. The flags themselves are better than my exclamation points as well. So looks-wise, it does seem to work well. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it looks like it does work basically how I want it to. So functionality-wise, it is nice. It got me where I needed to go in about 1/3 of the time. So let's go ahead and look at the code and see how it compares to mine. Okay, so this is the actual JavaScript that the code created. The HTML is very similar to mine, so we're going to ignore that. But let's go ahead and look at the JavaScript. They're hard coding the board size and the mine count. That's fine. I didn't tell it to do difficulty, but I imagine if I gave it another prompt, it could have. It's tracking board state in a variable like mine. It has game started. Mine was game running, game over. Okay. Timer, that's the same as mine. Seconds elapsed. A little different, but ultimately the same. So if you remember, mine also had an init game as well. In it, they're creating the board, placing the mines. They're calculating the counts separate from placing the mines. Interesting. Rendering the board and resetting everything. Okay, yeah. So that's pretty similar to mine. I think the main difference here is that they're placing the mines and calculating the neighbor counts separately, but we'll see how that works out. When they create the board, so it looks like this is actually creating the data for the board. And what it's doing is they're actually storing all of their information about each individual tile as an object. That makes sense. I think if I'd gone back to do mine, I might have added that in as opposed to just having a number. This way I could store more information. But, I did kind of like how I stored my information in the HTML itself as well. This way, when you get the click handler, you just receive the information from the attributes. But that's just more of a style change. Placing the mines is doing very similar to mine, where if the board doesn't have a mine, it's going to place it. The neighbor counts, interesting. So the neighbor counts is actually less efficient than what I'm doing. So if you notice here in the neighbor counts, when they calculate it out at the beginning, what they're doing is they're going to go over the entire board. So they're going to go first all the rows and the columns, and they're basically going to go over every single tile one by one. And then it's going to check for every single tile. It's going to check all of the neighboring ones to add up how many mines are nearby. So that's going to scale with the size of the board itself. As the board grows, then this particular function is going to take longer to run. Not a big deal for 9 by 9. Probably not a big deal either, even for my 22 by 22. But it's from an efficiency perspective. What I did, which was more efficient, is when I'm placing the mines, every time I place a mine, it's going to check the neighbors, the 8 neighbors, and update those numbers at that time. So mine is going to scale with the number of mines. So, in the 22 by 22 case, that's 400 some iterations that it has to go through at checking every single neighbor. Mine will just do 100 because they're doing the, every tile, mine's doing mines. So, algorithm wise, not ideal, but I don't know how much of performance is an issue with this. It is making the code itself more complicated because you have to actually have this get neighbors function. I didn't need that. So they have a render board function. One thing I like that I could have done, number one, they're using grid. That's nice. I did not use grid in mine. I just used Flexbox. But considering that the game board is a grid, it is nice that it actually used CSS grid. I've used Flexbox a lot over the years, but I really haven't had a chance to use grid very much. I'm a little bit behind the times on that. So I admit that in this case, AI picked a better CSS technology than I would have picked. just because of my familiarity. So that's great. But when it's rendering the board, again, it's iterating over every single tile and creating the tile elements. Okay, that's what I did initially to create the board. So that's here where it's going to, oh, I see. Okay. So it looks like it's going to render it every single time something changes. In my code, every time something changes, I'm just changing the tiles that are affected. So you click one tile, that one tile is going to flip. And so that'll be nice and quick. That's a, N of one or O of one for how computationally intensive a click is. Here, whenever you change something, it's going to update the data. I imagine further down, here's revealing the tile, handle tile click. We reveal the tiles and then we render the board. So this render board, which runs every single time something is clicked, is going to have to go across every single tile. So every time you click something, it'll be, in this case, 81 different calculations to re-render the entire board, even though, typically only one tile will change, or I imagine if they're doing they're updating all of this logic for the white spaces that I did. They're doing that as well. So those will get calculated and then the whole board will re-render. Flagged, yes. And then what we'll see is if we go down, so don't reveal flag tiles. That's nice. I didn't do that. If you hit a mine, the game is over and it ends the game. And I imagine end game will change the status icon, handle the right click. Pretty straightforward. It's pretty much the same as mine, just the if statements that cycle through. Timer, same thing, using an interval with 1 second intervals. I calculate mine, they just increase the seconds elapsed. There actually is a problem with this in that the timer is not guaranteed to be exactly 1 second. If the JavaScript thread queue is you doing something else, it could be off by a certain number of milliseconds. So this could drift over time where you're incrementing the seconds. That's why I actually chose to recalculate the number of seconds since our start time every time the display is, or the timer triggers. So this is something to think about if you're actually doing something that relies on very precise time calculations. You don't want to just use set interval and then increment. Just something to keep in mind. Update mine counter is doing, oh, interesting. Okay, so yeah, so again, update mine counter, whenever the flag is changed, we then have to go through and figure out just run through the data source and figure out how many flags have actually been set before we update that mine count. Again, mine is just when you click it, it's going to increment or decrement, and it's not going to have to loop over all 81 pieces of data. Yeah, last, there's going to be when the game is loaded, we're going to go ahead and init the game. We're going to add the event listener for resetting the game. So that was interesting to compare the two. In the pro AI side, the design was definitely nice, and getting that design just by prompting once and having it generate everything is fantastic. That some of the design stuff definitely took me a while just to get basic CSS down. So that's nice. Time is another thing that's really nice. Again, I said mine took 3 hours. This took 1 hour. So getting this code done in a third of the time. If you could imagine, if you extrapolate that out to something more complicated, getting 3 times the output is a huge deal. But on the cons, I would say on the side that could be improved, the AI wasn't as efficient in its algorithms it's used in order to implement the solutions. So as I mentioned, rendering the game board, it rendered it every single time as opposed to just rendering the affected tiles, which is all you really need to do for HTML. When it calculated out the initial mines, it again had to go through the entire board to figure out where the mine counts, as opposed to just incrementing the numbers when the mines are laid themselves. That'll reduce the number. And then just the potential timing problem that can be off by a couple seconds over a long period of time when in the set interval, which is a pretty obscure bug. But if this is something time sensitive, that would be something that you might not notice for a long time and be wondering why it's broken if you didn't know how this all worked. That's why it's good to review the code and actually know how it works. And that's why having fluency in the language or framework or the code that it's generating is going to be a huge advantage for those of us that are actually using AI versus those that are just using AI to generate stuff and hope that it works out of the box. I think I'll go ahead and add this code over to the existing GitHub repository where I'm storing the other Minesweeper code. This way, if you wanted to compare it and see how it differs, you can go ahead and pull that down yourself. The description below will explain where those files are and how to get them if you're curious. If you have any stories about reviewing AI code, positive or negative, leave them in the comments below. Thanks for watching, and I'll see you next time.